Growing plants in nurseries for use in gardening, reforestation and landscape restoration is a major agricultural activity in many European countries. An estimated 127,000 hectares are devoted to nursery crops in Europe. Many of these plants are grown outdoors in containers full of substrate, which means that natural soil is not used. This soilless culture growing technique facilitates agronomic management and makes transplanting in the soil easier. Plant containers are usually arranged on the ground on large permeable plastic sheets and are watered and fertilized at the same time using automatic drip feed and sprinkler irrigation systems. This allows nurseries to apply the right amount of water and fertilizer in solution form. However, agronomic reasons make it necessary to apply more water than plants actually need. This excess irrigation water is called leachate and is commonly seen in the growing area and in nearby water courses. The leachate generated by nurseries are aqueous solutions that usually contain dissolved nutrients. Some of these nutrients, especially nitrates and phosphates, are potential contaminants because they can pollute surface and subsurface waters if they are released into the environment. Current European legislation makes it obligatory to treat the leachate generated by plants not grown in natural soil, as in the case of nurseries growing container plants, when nitrate and/or phosphate concentrations exceed the maximum limits established by the regulation. To reduce dumping of potentially contaminating nutrients into the environment and also improve efficiency in the use of water, a scarce resource, and fertilizers, techniques should be used to collect and recover leachates from nursery growing areas for reuse in irrigation by creating a closed recirculation system. In soilless vegetable and cut flower production in greenhouses, recirculation techniques are highly developed and also economically viable in certain socioeconomic contexts. At nurseries and other sites where soilless culture is used, techniques should be implemented so that leachates can be filtered and reused in irrigation water. Any suspended pathogen propagules have to be eliminated from leachates, and techniques should also be available for on-site treatment of generated leachates to reduce the load of potentially contaminating nutrients like nitrates and phosphates. Technical development and implementation of leachate recirculation and treatment systems in nurseries is highly limited, and most European nurseries do not actually have systems of this kind. IRTA has therefore developed the CLEANLEACH system, an innovative solution for comprehensive on-site leachate recovery and treatment that makes it possible to increase the efficiency of water and fertilizer use, while treating leachates to reduce their contaminant content to admissible limits. The system thus helps increase the sustainability of nurseries and helps them comply with European regulations in terms of the management of leachates generated by soilless culture. The CLEANLEACH system can be implemented at nurseries and other sites, such as plant installations used in architecture and vegetable and cut flower farms that use soilless culture techniques in greenhouses and outdoors. The CLEANLEACH system basically consists of two parts. The first is a horizontal sand filtering system under the growing area. Without taking up extra space, it makes it possible to collect, filter and eventually eliminate any pathogen propagules contained in the leachate. The second part of the system involves the use of a horizontal surface flow constructed wetland adjacent to the growing area. This wetland uses a pre-filter to eliminate dissolved phosphates, which is followed by the action of denitrifying bacteria that eliminate dissolved nitrates in leachates by transforming them into nitrogen gas that is released into the air. The resulting effluent is thus free of pollutants and can be released into the environment or can be recovered for use in the irrigation system after suitable mixing. The treated leachate can then be stored and later returned to the irrigation circuit using a three-way valve to create a closed circuit. The horizontal sand filtering system is built by digging a shallow space under the growing area. This dug-out area should have longitudinal and transverse slopes to channel leachates to one edge of the plot of land. The dug-out area is then lined with plastic sheet to create a waterproof barrier. A drainage pipe is installed along its entire length and then covered with a layer of gravel to prevent it from becoming blocked. The dug-out area is then filled with large-grained sand to ensure the leachate from the containers is filtered and then channeled to one end of the sand filter, where it can be collected. A sheet of microperforated plastic is then laid over the layer of sand to finish the construction of the horizontal filter on which the container plants will be grown. A metal strip is attached to the end of the drainage pipe and to the waterproofing plastic sheet on the filter. A tube is connected that channels the leachate to storage containers. A motorized three-way valve allows the leachate and irrigation water to be mixed. The right amount of soluble fertilizer is then added to recompose the original nutrient solution. This effectively closes the cycle, recovers the water and nutrients contained in the leachate, and prevents the leachate from being dumped into the environment. The second part of the CLEANLEACH system involves the use of a horizontal subsurface flow constructed wetland adjacent to the growing area. The wetland comes after the pre-filter, to which a specific product has been added so the soluble phosphorus contained in the leachate is immobilized and part of the dissolved potassium bonds to the substrate in the pre-filter thanks to its exchange capacity. The horizontal subsurface flow constructed wetland that comes after the pre-filter is constructed by digging out a shallow area and then lining it to create a waterproof barrier, filling it with inert granular material and planting microphyte species typical of the natural wetlands in the surrounding area. Before the leachate enters the wetlands, a specific quantity of a source of non-synthetic carbon is added, so the carbon-nitrogen ratio of the effluent to be treated is prepared so that the nitrifying bacteria can work properly. Bacteria are naturally attracted to the constructed wetland and promote the transformation of dissolved nitrates in the leachate into nitrogen gas released into the air. As a result of these processes, in the pre-filter and the wetland itself, the phosphorus and nitrate content of the effluent leaving the wetland will be lower than the threshold levels established as admissible in the regulation. The effluent may therefore be released into environment or returned to the irrigation system.
El projecte CLEANLEACH és un projecte cofinançat pel programa Eco Innovation de la Unió Europea que pretén, en general, millorar l'eficiència en l'ús dels recursos i disminuir l'impacte ambiental de les activitats que financia. En concret, aquest projecte CLEANLEACH el que pretén és comercialitzar el sistema fent que l'eficiència en l'ús de l'aigua i dels nutrients en els nostres vivers millori. Per un altre cantó, millorar alguns aspectes del sistema estàndard per fer-lo més eficient i, finalment, aplicar aquest sistema a altres usos, com poden ser les cobertes vegetalitzades o com pot ser els cultius d'horta a l'exterior o dintre de l'hivernacle.
The CLEANLEACH Project was created through the cooperation of one research institute, IRTA, and 3 European Union SMEs, 2 from Catalonia, Naturalea and Bures Innova, and 1 from the United Kingdom, Salix.